Hi class, so in this video we will continue with our next topic, which is your gas turbine power plant. Alright, let's try to answer this question first. So you have air enters the compressor of a gas turbine engine at 350 Kelvin and 100 kilopascal. So basically this is your initial state. It is then compressed to 750 kilopascal with 580 Kelvin. Heat is transferred to the system in the amount of 100,000 kilojoule per kg. So heat is transferred to the system basically means that it is a Q in. Before it enters the turbine, which has an efficiency of 85% of work. So now you know that your turbine is no longer work 100% efficiency. Alright, so let us plot this thing first. Alright, so you have a gas turbine work. So this is your temperature, this is your S. Since it doesn't mention that you have a regeneration, so you have a 2 pump or 2 turbines, so this is basically only 1 pump and 1 turbine case. So this is your state 1, where the air is initially at 100 kilopascal. So this is your constant pressure line. And your initial temperature given is 350 Kelvin. And then next it is compressed to 750 kilopascal with temperature of 580 Kelvin. And then what happened next is that this is your second stage. So this is the process of heat addition at constant pressure. So given to you your Q in. Your Q in is equal to 1000 kilojoule per kg. And this is your state 3. And finally you are going up from your turbine state. And you have been given the efficiency of your turbine, which is 85%. So automatically you are going to have an actual work over here. So this state will be your 4A, and this is your Q out. Alright, so you were asked to sketch the cycle on a TS diagram. So this is your cycle on a TS diagram. You need to find the actual temperature of the air before and after it enters the turbine. So if this is your turbine, so you need to find the actual temperature of the air before and after it enters the turbine. So before the turbine is actually your T3, and after your turbine is actually your 4A. So let's just write here what you are looking for, which is your T3 and your T4A. And then next you need to find your back work ratio, and then your thermal cycle efficiency, and you have this one, new thermal efficiency if the turbine efficiency has been increased by 15% from its original value, and briefly explains your findings. Alright, so this is you need to think a little bit, right? So the first part, it says that you have 85% efficiency, and now if you increase the turbine efficiency by 15%, means that 85 plus 15%, you are going to have 100% of work. So you need to briefly explain what is your findings based on this 100% efficiency. Yeah, you can show or justify your explanations using calculation as well. Alright, so given to you constant specific heat 1.005, this is at constant pressure, this is specific at constant volume, and it's also given to you gas constants and your K value.